All right, so you want to get into Kubernetes Ingress, but you're kind of looking for a shortcut, like a way to skip setting up a whole domain name.
Yeah.
And you know what? You're not alone. That's why today we are taking a deep dive into this unconventional approach, using Kubernetes Ingress without relying on a domain name. It's almost like trying to navigate a city using landmarks instead of street addresses. Tricky, but doable, right?
That's a really great analogy. It really highlights both the challenges and the benefits. In a typical setup, Ingress relies on those domain names to route traffic to the right services within your cluster. Think of it like a mailroom, sorting letters based on addresses. But what if we want to bypass those addresses and use something else, something less formal? That's where this IP-only method comes in.
Okay, I'm intrigued, but I'm also a little skeptical. How do you even access services without a domain name?
Well, instead of typing in something like myapp.example.com, you would use the IP address of your Ingress controller, followed by a specific path, like this: http://103.123.123.123.123 myapp.part. That's the key. It's like a secret code that tells the Ingress controller, hey, this request is meant for the myapp service.
So it's all about those paths, those little breadcrumbs leading to the right service. But I'm guessing it's not as simple as just slapping a path onto an IP address. There's got to be some configuration magic happening behind the scenes, right?
You're absolutely right. Let's say you are using the popular NGINX Ingress controller. You typically deploy this using Helm, which is like a package manager for Kubernetes. Think of it as an app store for your cluster. It makes it really easy to install and manage different tools and services.
Helm, got it. So once we have our NGINX Ingress controller set up, how do we tell it to use those paths instead of host names?
This is where the Ingress resource comes into play. It's a YAML file where you define the rules for how Ingress should behave. In a typical setup, you would have a host field in this file, specifying the domain name. But in this case, we leave that field blank, and we focus solely on the paths.
Okay, so no host, just paths. Can you give us a peek into what this YAML magic looks like?
Absolutely. Let's say you have two services, App1 and App2. In your Ingress resource, you define separate rules for each, specifying the path and the corresponding service. It would look something like this.
Hold on. Let's actually visualize this. Imagine you're typing this into your browser. For app 1, you would type in http://123.123.123.123 AP1. And for app 2, it would be http://123.123.123.123 AP2. It's like we're adding those extra signposts after the main address.
To point to the right destination.
Exactly. But as you can imagine, this can get pretty messy. If you have a lot of services, imagine trying to manage a whole city with only landmarks, no street names. It would be chaos.
And that brings us to the first potential downside of this approach.
Right.
Things can get unwieldy. As your application grows, it becomes a real challenge to keep track of all those paths, especially if you have multiple teams working on different parts of the application. Plus, what happens when you want to use a more descriptive path, like user profile? You might end up with conflicts if two services try to use similar path.
Right. A regular domain name setup with host names and subdomains just makes things so much more organized. You can have app1.example.com and app2.example.com. No path juggling required.
Exactly. But that's not the only advantage of using a domain name. What about security? Especially HTTPS.
That's a big one. Most certificate authorities won't issue SSL certificates for just an IP address. They need a verifiable domain name to ensure that you are who you say you are. It's like trying to get a driver's license without providing any identification.
That's a great way to put it. So, while you could technically use self-signed certificates for HTTPS, with an IP address, they're generally not recommended for production environments.
Because those self-signed certificates, they'll trigger those scary security warnings in browsers.
Right.
Like, proceed with caution. This site might be trying to steal your data. Not exactly the user experience you want.
Definitely not, especially if you are dealing with sensitive information. So if we are talking about best practices, using a domain name with proper HTTPS is definitely the more secure and user-friendly approach.
Okay, so we've got potential path-based routing headaches and HTTPS security concerns. Anything else we should be aware of when venturing down this no domain name path?
Well, there's the issue of the host header. Some Ingress controllers, like NGINX, really rely on this header to figure out where to route traffic, like a little note attached to the request, saying, hey, I'm meant for this specific host.
But if we're not using a domain name, wouldn't that host header be missing?
Exactly. So in some cases, you might need to manually set the host header in your requests using a tool like curl. It's a bit of a workaround, but it can be necessary to get things working properly.
Okay, so it's not always as straightforward as it might seem. We have to be mindful of the potential complexities and limitations of this approach. But before we dive deeper into those, curious, are there any situations where using ingress without a domain name actually makes
You
sense?
know, there are. Let's say you are just starting out with Kubernetes and you want to experiment with Ingress. Without getting bogged down in DNS configurations, this IP-only method can be a great way to learn the ropes and get a feel for how Ingress works.
It's like a,
Yeah, Ty.
a training wheels approach, a
Yeah.
way to grasp the fundamentals
Yeah,
before moving on to the real deal.
exactly. It allows you to focus on the core concepts without the added complexity of setting up a domain name. Plus, in some development environments, speed and simplicity are key. Maybe you just need to quickly expose a service for internal testing,
Yeah.
and you don't want to go through the hassle of configuring a domain.
Right. It's like a quick and dirty proof of concept. Like,
Mhm.
does this ingress thing even work?
Right.
Okay, cool. Let's move on to a more robust setup. But I'm guessing that as things scale, that simplicity starts to break down.
Absolutely. As your application grows, and especially as you move towards a production environment, the limitations of this approach become more apparent. Managing a complex web of paths becomes a nightmare. Security concerns become more pressing, and you start to really miss the organizational power of a domain name.
So it's a trade-off,
Yeah.
a balance between simplicity in the short term and robustness in the long term.
Yeah.
We're starting to get a clearer picture of when this IP-only method might be useful
Okay.
and when it's time to embrace the power of a domain name.
Exactly. And to understand that trade-off even better, let's dig deeper into those limitations, those
Yeah.
challenges. That might make you rethink using Ingress without a domain name, shall we?
Okay, we've kind of hinted at some of the security risks of going domainless,
Mm-hmm.
but let's really unpack those because,
Yeah.
let's be honest, security is always top of mind,
Mm-hmm.
especially when we're talking about exposing services to the outside world.
Absolutely. And the stakes are even higher when you are using a public IP address directly. Think about it. Anyone who knows that IP address can potentially try to access your services. It's like leaving your front door wide open with a neon sign that says, "Come on in."
Yikes. That's not exactly the welcome message we want to send to potential attackers. With a domain name, you at least have that extra layer of control. It's like having a gatekeeper who checks for credentials before letting anyone in.
Exactly.
Yeah.
And when you add HTTPS into the mix, you are essentially building a fortress around your services. The encryption that HTTPS provides makes it incredibly difficult for attackers to eavesdrop on or tamper with the traffic between the client and the server.
Right. It's like sending your messages in a super secret code that only the intended recipient can decipher. But here's the thing. Getting a proper SSL certificate for HTTPS usually requires a domain name. Those certificate authorities, they are sticklers for verifiable identities.
They are. And for good reason. It's all about establishing trust on the internet. Imagine if anyone could just create a fake website
Wow.
and get an SSL certificate for it. It would be chaos. So, while you can use self-signed certificates with an IP address, they're not ideal for production environments.
Because those self-signed certificates will trigger those dreaded security warnings in browsers. And let's be honest, those warnings make even the most tech-savvy user a bit nervous. It's like that feeling you get when you see a dimly lit alleyway. You know you could walk through it, but maybe it's better to take a different route.
I love that analogy. It perfectly captures the hesitation that those warnings evoke. And that hesitation can lead to lost trust, lost users, and ultimately, a less secure online experience for everyone.
So, if we are talking about security best practices for an ingress setup without a domain name, what would you recommend? What steps can we take to mitigate those risks?
Well, the first and most important recommendation is to avoid using this method in production environments, unless it's absolutely unavoidable.
Agreed. It's just not worth the potential security headaches.
Exactly. But if you absolutely must use a public IP address, there are some measures you can take to reduce the risk. One option is to implement strict network policies. It's like having a virtual security guard who checks everyone's ID at the door.
Okay, so I'm picturing a bouncer at a club, making sure only people on the list get in.
Right.
So, how do network policies work in the context of Kubernetes?
Well, with network policies, you can define rules that restrict access to your services based on various criteria, such as IP addresses or ranges, for example. You could create a rule that only allows traffic from your company's internal network, blocking all other requests.
It's like creating a whitelist of trusted sources. Anyone not on the list gets turned away. That makes sense.
Exactly. And you can also implement strong authentication and authorization mechanisms to control who can access your services. It's like adding an extra layer of security checks. at the entrance to your most valuable rooms.
Right. So even if someone manages to bypass the initial security measures, they still need the right credentials to get in. And of course, keeping your Kubernetes cluster and all its components up to date with the latest security patches is essential.
Absolutely. Security is an ongoing process, a constant game of cat and mouse with potential attackers. You can't just set it and forget it.
Okay, so we've explored the security implications in depth, but you mentioned earlier that there are situations where using Ingress without a domain name might actually be a viable option. Can you give us some real-world examples?
Absolutely. I once worked with a team who were developing a highly experimental project, and they needed to get a prototype up and running quickly for internal testing. They weren't concerned about security at that stage. It was all about speed and flexibility.
They're that move fast and break things phase.
Exactly. They just needed a way to quickly expose their services within their internal network. Using a public IP address with path-based routing was the fastest and easiest solution for them.
That makes sense. It's a good reminder that sometimes the simplest solution is the best, especially in those early stages of development. But as the project evolves, and especially as you move towards production, the need for robustness and security increases.
Absolutely. It's a natural progression, a journey from simplicity to robustness. And the choice of whether or not to use a domain name with Ingress reflects that journey.
That's a great point. It's not just about the technical aspects, but also about understanding the context of the project and its current stage of development. Now, before we shift gears and explore some alternative approaches, I want to circle back to the YAML manifest for the Ingress resource. We touched on it briefly earlier, but I think it's worth digging a little deeper.
I agree. The YAML manifest is where the magic happens. It's where you define the rules of the game, so to speak.
Exactly. The source we're working with provided an example manifest. And one of the things that caught my eye was the path type field. The example set it to prefix. I'm curious, what other options are there, and how do they affect the routing behavior?
Great question. Path type is a crucial part of the Ingress configuration. It determines how the Ingress controller matches incoming requests to the paths you define in your rules.
With a prefix set, any request that starts with that path gets routed to this corresponding service. It's like a wildcard match.
Precisely. So if you have a rule with the path myapp and path type set to prefix, any request that starts with myapp, like myapp profile or myapp settings, be routed to that service. It's like casting a wide net to catch all those requests.
Interesting. What are the other options for path type?
Well, there's exact, which means the path has to match exactly. No wildcards, no partial matches. It's like a laser-focused beam, only hitting requests with that precise path.
So, if you have a rule with a path myapp and path type set to exact, only requests for myapp would be routed to that service. Any other path, even something like myapp, would be ignored.
Exactly. It's very strict. And then there's implementation specific, which is a bit of a wild card. It basically says, hey, Ingress controller, you decide how to handle this.
Okay, so a bit more flexibility, but also a bit more ambiguity. You have to trust that the Ingress controller knows what it's doing.
That's right. It's important to consult the documentation for your specific Ingress controller to understand how it implements this option.
So in our example, using prefix makes sense because we want to capture any request that starts with that particular path.
Exactly. It's the most flexible option for this type of setup.
Another thing I noticed in the manifest was the annotation for disabling the SSL redirect. The source mentioned that this was specifically for HTTP traffic.
Right, because we are not using HTTPS in this scenario. That annotation basically tells the NGINX Ingress controller, hey, don't bother trying to redirect HTTP traffic to HTTPS. It's not going to work.
Which makes sense. Since we don't have an SSL certificate set up, it would be like trying to redirect someone to a secure room that doesn't exist.
Exactly. It would just create a confusing and frustrating experience for the user.
So, even though we're not using a domain name, this YAML manifest still gives us a lot of control over how Ingress behaves. We can fine-tune the routing rules, security settings, and other important aspects of our configuration.
Absolutely. And understanding the different fields and annotations in the manifest is crucial for getting the most out of Ingress. Regardless of whether you're using a domain name or not, it's like having a detailed blueprint for how your traffic should flow.
That's a great way to put it. It's all about understanding the intricacies of that blueprint and how to manipulate it to achieve our desired outcomes. But I think we've explored the YAML rabbit hole enough for now.
Indeed we have. And we've covered a lot of ground in this part of our deep dive, haven't we? We've delved into the security considerations of using Ingress without a domain name, explored some real-world use cases, and even dissected the YAML manifest to uncover its secrets.
It's been quite the adventure. And we've gained valuable insights into both the potential and the limitations of this unconventional approach.
We have. But the exploration doesn't end there. What if I told you that there are other ways to use Ingress, without relying on a public domain name, ones that might address some of the challenge we discussed?
Intriguing. I'm always up for exploring different paths.
Excellent. Let's dive into those alternative approaches in the final part of our deep dive.
All right, so we've explored this world of Ingress without a domain name, the good, the bad, and potentially ugly. But what if you need a little more structure, a little more elegance, Without jumping through all the hoops of setting up a full-blown domain, are there any middle ground options?
There are. Let's talk about nip.io. It's a dynamic DNS service that lets you create temporary host names based on, wait for it, IP addresses. It's like having a pop-up naming service for your cluster.
Okay, I'm all for convenient workarounds. How does this nip.io wizardry work?
It's surprisingly simple. You take your IK address, let's say it's 123.123.123.123, and you just stick .nip.io at the end. Boom, you've got a host name, 123.123.123.123.nip.io. No messing around with DNS records, it just works.
Wait, so I can just start using that host name right away? No waiting for DNS propagation, no complex configurations?
Nope. Nip.io handles all the behind-the-scenes magic. It's like having a personal DNS fairy godmother.
I love it. But how do we actually use this with Kubernetes Ingress? Do we just replace the domain name
Yeah,
with our fancy new nip.io host name?
exactly. In your Ingress resource YAML. Instead of specifying a host value, you would use your nip.io hostname. So it would look something like this. Host 123.123.123.123.nip.io.
So from a user's perspective, it's like accessing any other website with a domain name. They wouldn't even know it's a temporary setup. Sneaky. But this begs the question, why even bother with this? Instead of just using the IP address directly?
Well, for starters, it's way more user-friendly. Typing in 123.123.123.123.nip.io is a lot easier than remembering a string of numbers, especially if you have multiple services to access. Plus, it allows for better organization. You can create separate host names for each service, making routing and management much cleaner.
Okay, so points for convenience and organization. But what about security? Does using nip.io give us any advantages there?
It can, indirectly, because you now have a host name. You can potentially set up HTTPS using a wildcard SSL certificate. For the .nip.io domain, it's not a perfect solution, but it's a significant step up from plain HTTP.
So we are back in the realm of encrypted messages and happy browsers. Not bad for a temporary setup. So nip.io seems like a great compromise. Quick, relatively easy, and with the potential for improved security.
It's a valuable tool to have in your Kubernetes arsenal, but there's another alternative we haven't discussed yet, using a local DNS server, like DNSMask.
DNSMask, I've heard whispers of its powers in the networking world. It's like a Swiss Army knife for DNS, right?
That's a great way to put it. It's a lightweight DNS server that you can use for all sorts of things, including resolving custom host names to specific IP addresses within your local network.
So instead of relying on an external service like nip.io, I could set up DNSMask on my network and tell it to resolve, like .myapp.local, to my Ingress controller's IP address.
Exactly. And then anyone on your network could access that service using that local host name. It's like having your own private little internet.
Okay, that sounds pretty cool. But how does this approach compare to using nip.io? Is it easier, harder, more secure?
It is a bit more involved in terms of setup. You need to install and configure DNSMask, and you need to ensure that your clients are using it as their DNS resolver. It's not as plug-and-play as nip.io, but it gives you more control over your DNS resolution.
There's a trade-off between convenience and control.
Yeah.
Nip.io is quick and easy, but DNSMask give you more fine-grained control.
Precisely, and it could be a good option if you're already using DNSMask for other purposes on your network. It allows you to keep all your DNS configurations in one place.
So we've gone from the bare-bones IP-only approach to the convenience of nip.io, and now to the control of a local DNS server. It's like a choose-your-own-adventure for Ingress setups.
That's a great way to think about it. And it highlights the flexibility of Kubernetes and the fact that there's no one-size-fits-all solution.
Exactly. It's all about understanding the different options, weighing the pros and cons, and choosing the approach that best fits your specific needs and context.
Couldn't have said it better myself. By exploring these different paths, we've gained a deeper understanding of not just the technical aspects of Ingress, but also the decision-making process behind choosing the right setup.
And that's what this deep dive has been all about. We've journeyed into the unconventional, uncovered some hidden gems, and hopefully spark some new ideas along the way.
I hope so too, because at the end of the day, it's all about finding the solutions that empower you to build, deploy, and manage your applications with confidence and clarity.
Well said. And on that note, I think it's time for us to surface from this deep dive. But before we go, let's leave our listeners with a final thought-provoking question. Knowing what we know now, how would you approach choosing between these different methods for a real-world project?
That's a great question to ponder. It's a decision that requires careful consideration of the project's requirements, security needs, and long-term goals. There's no right or wrong answer, but hopefully, this deep dive has given you the knowledge and tools to make an informed choice.
Absolutely. So until our next deep dive, keep exploring, keep learning, and keep pushing the boundaries of what's possible with Kubernetes.
And beyond.